7.6 is the last section that we're going to be covering for this chapter. And starting with logs, for the first time, we've talked about rewriting, we've talked about how exponents and logs are inverses, we've talked about graphing, how they relate to growth and decay, how to condense, how to expand. The last thing that we're going to be talking about is how to solve them. And that's what we're going to be doing today and tomorrow. And when we talk about solving exponential equations or solving log equations, a lot of stuff goes into them. That's why it's the last concept of the chapter. You have to really have a grasp on everything that we've talked about in the past in order to solve them. Okay, so we're going to be solving, so going all the way down to x equals, but we got to be able to use all the concepts and all the tools that we've had from the first 5 sections in order to solve. Now, first thing, there are 4 types, as it says up at the top. Today, we're going to be looking at the first 2 types. Okay, so type 1 and type 2. Tomorrow we're going to be looking at the second 2 types, type 3 and type 4. Each day has one type that's pretty easy, pretty basic, and the other one that's a little bit harder. Okay, so type 1 today is going to be the easy one. So type 1 for solving. It says if 2 numbers with the same base are equal, then their exponents must be equal. Okay? Well, if I'm talking about base in the sense of exponents, I've got an exponent. The base is the number that the exponent is attached to. Okay, so in my simple example down here, my base is 2. Okay, so the first key is the base has to be the same. So I've got a 2 and a 2. Okay, so check mark, they're the same. It says if the bases are the same, then, here's the key, the exponents have to be equal. Well, why does that make sense? 2 to what power equals 2 to the 16th? Well, that has to be 2 to the 16th equals 2 to the 16th. So what's your answer? X equals 16. Okay, but the key, again, is these bases have to be the same for you to be able to make that connection. Okay, so let's look at a couple examples that are a little bit more difficult than this one. Now, the first one, 2 to the 4x equals 32 to the x minus 1. First thing you should recognize is currently the bases are not the same. I've got a 2 and I've got a 32. So my job is, since they're not the same, is to make them the same. Okay, well, what can 32 turn into that'll be the same as over here? That's the first question that I always ask myself. Or can 32 turn into something that's the same? And for this case, it would be 2. Okay, we'll start thinking of your 2's. 2 squared is 4, 2 cubed is 8, 2 to the 4th is 16, 2 to the 5th is 32. So that's the first thing that you got to see is, can I change this bigger number and make it turn into the smaller base, which I can. 32 is 2 to the 5th. Okay, so I'm going to have to take this 32 and change it into 2 to the 5th. Okay, well, I'm not touching this side. This is still 2 to the 4x. The 32 is now 2 to the 5th, okay, but this x minus 1, you need to make sure that when you change this into a 2 to the 5th, this 5 has to be outside of everything that you had. So it's got to be outside of the x minus 1, which means you need parentheses. Okay, well, if I need parentheses here, what does that mean? This is not 2 to the 5x minus 1. This is 2 to the 5x minus 5. You got to pull that 5 into everything that you had up there in the power. Okay, now what was the key? If we can get the bases the same, these powers have to match. So this 4x has to match this 5x minus 5. But the key is we had to make the 2's the same first. So since they're the same, now I can pull my powers. 4x has to be the same as 5x minus 5. Now, simple solving. I'm going to go ahead and move my x's over to the left, so I'm going to subtract 5x. So what does that mean? 4x minus 5x is negative x equals negative 5. I'll divide everything by negative 1 to get rid of that negative in front of the x. So what's x? X equals negative 5 divided by negative 1 is 5. Okay, let's look at the next one. 64 and 16. Ooh, a little bit more difficult. Okay, first question. Can 64 turn into 16? 16 squared is a lot bigger than 64, okay? So that's the first trigger in your head. That's not going to work. So if 64 can't turn into 16, they're both going to have to change, okay? And I would start with the smaller number. 16, I've got two options here. It's either 2 to the 4th or it's 4 squared. Both of those give me 16. Okay, well, I actually could do either one with 64. I could do 2 or I could do 4. Okay, so I'm just going to choose 4. I need to make them the same, so I'm going to choose 4. I'm going to turn the 16 into 4 squared. 4 to what power is 64? 4 cubed. Okay, so in this case, I have to change them both. So 64 is 4 cubed, and then I've got an x up here to go with that 3. 16 is 4 squared, and I've got this x plus 1 that I need to make sure I put in parentheses because I got to pull that 2 into my parentheses. So my base is the same. So since my base is the same, that means these powers have to also be the same. So this 3x has to equal 2 times x plus 1. Okay, well, let's solve. 3x has to equal, pull my 2 in, 2x plus 2, subtract 2x, x has to equal 2. Now, number 3, a little bit more challenging. It really stretches your mind because we have fractions here, and you guys don't like fractions. So I have 4 to the x equals 1/2 to a power of x minus 3. Now, with this question, there's two things that I've got to recognize, okay? First, do I want to turn the 1/2 into a 4, or do I want to try to turn the 4 into a 1/2? Okay, that's the direction I'm going to choose to go. I'm going to turn the 4 into a 1/2. Now, first thing, I know I said 1/2, but I'm going to concentrate on the 2. If 4 were a 2, how would 2 turn into 4? And that's the question that we got to get into our head. How would 2 get to a 4? Well, that would have to be 2 squared. Okay, well, that satisfies this bottom. But I said 1/2, not 2. Okay, well, question. 1 squared is 1, 2 squared is 4. But this isn't 1/4, this is 4 over 1. Okay, so instead of a 1/4, I want a 4. Well, how do you take a fraction and flip it? The power needs to be negative. So 1/2 to a power of -2 is 4. Okay, so I took my 4, changed it into a 1/2. So this is 1/2 to a -2, which is 4. Got to put my x on there. Equals 1/2 to a power of x minus 3. Okay, so our 1/2s are the same. So since our bases are the same, we can say our powers have to be the same. So -2x has to equal x minus 3. Again, I'm going to move that x over. So I have -3x equals -3. Divide both sides by -3. X equals -3 divided by -3 is 1. Okay, so that one's a little bit more difficult because you have to figure out how to change and which one you want to change. But the concept is still the same. Once the bases are the same, your powers have to also be the same. So that's type 1 of solving. Type 2 of solving. We're going to have to rewrite some exponential equations as log equations. Okay, so in this type of question, the x is going to be an exponent, and we're going to have to pull it down. And in order to pull it down, we're going to have to rewrite it as a log. Okay, so if I look at this first one, the x is an exponent. So in order to rewrite this and pull the x down where I need it in order to solve, I'm going to have to rewrite it. Now, a couple sections ago, remember I said when you're rewriting as a log, fill in your blanks and just fill them in order when you do your circle. So you start at your base, b, so it's log base b. Do your circle of y, go back across, equals x. And that's how we get to here. Okay, so that's our inverse. So when we're doing this, simple concept. Start with the power on the left, and then just fill in your blanks one at a time. Okay, so first example, 4 to a power of x equals 15. Okay, well, first thing you should recognize, x is a power. Okay, it's the first time that you've seen x as a power and being able to solve x as a power. So we have to get it down where it belongs in order to solve. Well, in order to get it down, we have to figure out our inverse. We got to figure out our circle. Okay, so when I do my circle, first thing, to keep everything consistent, keep your power on the left, just like we've had our logs on the left. So keep it on the left. So when we do our circle, everything stays the same. So I'm going to start at my 4, start at your base, go across to your 15. So I have log, and again, you're filling in your blanks. Log base 4, do your circle, of 15 equals x. By doing that inverse, by doing that circle, it allows us to take this x that's up in the power, and now it's no longer in a power position. So now I can solve for it. So log base 4 of 15 equals x. Well, there's only one step left to do in this question. How do I type this in my calculator? Okay, we can't type it in like it is, remember, because this is a 4, not a 10. So how do I type it in? I have to do change of base. Change of base, log of what on top, log of what on bottom. Again, since this base is a 4, I got to do change of base. So log of 15 over log of 4. Type it in. X equals 1.953. Okay, now when we look at number 5, hopefully again we recognize that x is up in a power. So we hopefully can see we're going to have to write a log in order to get that x down where it belongs. Now, first thing, basic rules of solving. Before I do any kind of a circle, any kind of an inverse or anything else, I have to get rid of the 3, just like any other solving question. You got to isolate. So I need to isolate that x. So in order to isolate, I got to move my 3. So step 1, subtract 3. 5 to the power of x minus 2 equals 25 minus 3 is 22. Now, the x as a power is isolated, and I have it on the left-hand side. Again, keep everything consistent. So now I need to do my circle. So I start with my base of 5. So log, then what's going down here? Base 5 of 22 equals x plus 2. So we took that x as a power, did our inverse, did our circle. Now that x is down where it belongs. Now we can finish solving. So same thing as what we did in the last question. This is not a 10, this is a 5. So what are we going to have to do here? We're going to have to do our change of base. So what is this going to look like? Log of 22 over log of 5. And now since this is an x plus 2, how am I going to solve for x? This is going to have to move over, right? So I'm going to have to subtract 2 as well. Okay, if you haven't yet, go ahead and start typing that in your calculator. We had to do change of base since we had a base of 5. So log of 22 divided by log of 5. And if you want to, you can press enter. And then we have to subtract that 2 to the other side, so minus 2. And you should get negative 0.079. Okay, so a little bit different than what we're used to in the past. Let's look at 2 more. 40e to the power of 0.6x equals 240. Okay, well, first concept again, x is a power. So I know I'm going to have to be rewriting this in order to bring that x down. Okay, isolating. X is attached to e. It is not attached to that 40. So your key to isolating, just like in the last question, we had to get rid of the 3 in the last question. So in this question, this 40 has nothing to do with the power. So how do I get rid of it? I need to isolate this power of x. So how do I get rid of that 40? It's 40 times, so I need to divide both sides by 40. So I have e to the 0.6x, 240 divided by 40 is 6. Now that x is isolated, and again, to keep everything consistent, it's isolated on the left-hand side. So we need to do our circle. Start at E, that's your base, right? And go across. Now, I've got two choices. I can write this as log base E of 6 equals 0.6x. You can, okay? But definition, we talked about several days ago, definition of log base E. This has a specific purpose. It has a specific kind of log. If that's a log base E, we don't actually write log base E. What do we write? Log base E is the natural log. So this is log base E. It is the natural log of 6 equals 0.6x. So you're never going to see it. Remember, you're never going to see it written as log base E. Log base E is ln. That's our natural log. So natural log of 6 equals 0.6x. Last step, since natural log of 6 is just a button, you can type that in your calculator, right? How am I going to get x by itself? I'm going to need to divide by 0.6. So natural log of 6 divided by 0.6. If you haven't typed it in yet, go ahead and do so. X equals 2.986. Okay, last one for today. E to the negative x equals 9. First thing, x is a power. It's attached to this e. Is there anything in front of e or anything behind e I need to get rid of? There's nothing in front, nothing behind, so there's no isolation I have to do here. So since there's no isolation, I'm doing my inverse. I'm doing my circle to take this x up here as a power and to bring it down. So am I going to write log base e since e is my base? No. Remember, we don't write log base e. When it's a base of e, we write ln. So ln of 9 equals negative x. Well, this one's pretty easy. Negative x, how do we make that a positive? Divide by negative 1. So I have negative natural log of 9 equals x. Type it in your calculator. Negative natural log of 9. You get negative 2.197. So our first steps to solving today, we had same bases, and then we also had x as an exponent. So tomorrow we're going to talk about type 3 and type 4, and then the key for the test will be differentiating between the 4 types. Again, here's your homework for those of you who are gone. Now one more day of notes for this chapter.